Good morning. Today we are going to discuss about batching and mixing. Before going into this, I am just going to recollect about the last lecture. In last lecture, we discussed about fresh concrete, a concrete which is freshly prepared, and it is a concrete which is mixed and it is in a plastic stage, then it is said to be a fresh or green concrete. A fresh concrete has some properties. A concrete which is freshly made and still a fresh concrete is the one which is freshly made and it is in plastic stage. It is called as either fresh concrete or green concrete. It has some properties. What are those properties? Properties of fresh concrete: setting, workability, bleeding and segregation, hydration and air entrainment. A fresh concrete is said to have these properties in it. Setting, it is nothing but the time which it takes to convert from plastic to solid state, that is called as setting. Next is workability, and we have discussed about this workability in the last lecture. That is, it is nothing but the ease with which the concrete can be worked, the easiness with which the concrete can be placed in a formwork. Bleeding and segregation. Bleeding is nothing but when a concrete is being placed in a formwork, after some time the water alone will tend to rise up and will form and will get stagnated on the top layer of the concrete. That is said to be bleeding, and that bleed water will give rise to many durability issues. And this segregation is the separation of concrete ingredients from one another, and this too will lead to serious durability problems. This hydration is again but the rate at which the concrete gains strength. This air entrainment is the freshly placed concrete. This air entrainment is when the freshly prepared concrete is placed in a mold. There it forms air voids during placing. So we have to prevent that air voids by doing compaction, that is air entrainment. These are the properties of fresh concrete. So we have to take care while preparing and placing a concrete to avoid these problems, like bleeding and segregation. So these are the properties of fresh concrete. Next, moving on to batching. Batching, it is the measurement of the ingredients which are going into the concrete. How a concrete production is done. Concrete production process. How a concrete production process is done. First, we have to batch it, that is batching. Next, we have to mix it, that is mixing. Then transport to the place where it is to be placed, placing. Then after placing, we have to compact it, and finally we have to cure it, and the end product is concrete required concrete. So this is how a concrete production process take place. Batching followed by mixing, then transport, placing, compaction, curing, and we will be getting the concrete of desired property. This batching is measuring the ingredients. In mix design, we saw about how to design a concrete mix, that is how the water cement ratio has to be fixed, and from that how the cement content should be arrived, water content should be arrived, and the other ingredients has to be arrived. Now we have to measure the correct quantity of those ingredients so that a concrete will be of the required desired property, so that we can get a concrete of desired property. It is the process of measurement of specific, that is the process of measurement of specified quantities of ingredients, that is cement, water, fine aggregate, coarse aggregate. If any mineral or chemical admixture is to be added, then that much quantities, that much specified quantities should go into the concrete. That measuring process is called batching. In this batching, we are having two processes. One is volume batching, next is weigh batching. This volume batching will, nowadays we are not using this volume batching. Even if it is used for a less even if it is used, then it is used for small non-engineered works. Here in volume batching, example 1:6 ratio, we will be fixing some ratio, and based on that ratio we will be using the ingredients 1:6. For example, 1 part of cement, 6 parts of sand. We will be specifying some volume, and based on that volume we will be measuring the quantities. That is, say suppose 1 cubic feet of a box. We are having a standard 1 cubic feet of box, and in that box we will be filling the ingredients and we will be using it for our work. Why this is of not much importance means we cannot control the mass within the volume. Why it is so? Since suppose in 1 cubic feet, one person will be filling the box of 1 cubic feet by rodding it, that is by tamping it, and other may fill it simply just like that and will travel off the top surface, so that the mass which is contained in that volume will not be the same in both the cases, so that controlling a mass within a specified volume is not that much easy, and so we are not using it for engineered concreting purposes. If it is used, then it is used for only small non-engineered works. And this weight batching is based on mass basis, and it is prescribed in IS 456-2000. In this weight batching, we are measuring the mass of the in this weight batching we are measuring the mass of the specified ingredients, so that there will not be much deviation as like that in the volume batching. There we had a volume, and based on that volume we calculated the mass, but whereas here we are measuring the specified mass of the ingredients alone. Suppose a cement is to be of 12 kilogram, then that 12 kilogram alone should be used, and it alone should be weighed and not more or less than that. So we are adopting for this weight batching. How to measure the ingredients? We have seen by volume and by weight batching, and we are going by weight batching. Next, in a typical batching plant, how they are measuring these quantities? We'll see that. In a typical batching plant, if a concrete is to be produced, then how it's being produced? We'll have a look at that. They should have separate bins for storing the aggregate and silos for storing cements and cementitious material, so that the concrete can be produced in an efficient manner. First, let us see the components of batching plant. First is aggregate, bins. Second, feeding mechanism. Third, balance and measuring system. Cement silos, storage tank for water, and dispenser for chemical admixtures. These are the components of a batching plant. These are the components in a batching plant. Aggregate bins. Why the aggregate should be stored in bins? Since if it is kept as such in the open environment, it may lead to contamination of the aggregates during rainy season or wind season. So to prevent that contamination, we are storing it in aggregate bins. Again, cement silos. Cement has to be stored in silos. That is, it should be kept free from water. So we are storing it in silos. And in this aggregate bins, in a typical batching plant, we will be having separate aggregate bins. That is, for different size of aggregates, we will be having separate bins. So they will be storing that particular size of aggregates in that bin. There will not be any mixing of aggregates. Next is feeding mechanism. How the stored aggregates and cement will be fed into the mixing area. This is through the feeding mechanism. How the aggregates of required quantity are selected from the bins and how the cement of required quantity is coming through the silos is through this feeding mechanism. Here we will be having either a screw type conveyor. Here we will be having either scrappers or conveyors or hoists to transfer the aggregates to the bins, to transfer the aggregate to the scales. Next is balance and measuring system. Here we will be measuring the required quantity of the ingredients. How this is being done, we will see in later. And cement silos, and from these silos the cement is being fed through the feeding buckets through screw conveyors or bucket conveyors. This storage tank for water, from where the water can be taken during the mixing process, and a dispenser for chemical admixture. If the chemical admixture is to be added to the concrete, then it has some system within it so that the required quantity of admixture can be added to the concrete during mixing. Now let's see these components in a typical batching plant. And this is how a batching plant will be. I have marked the parts: scrappers, silos and aggregate bins, and this is how a typical batching plant with all its components is being shown there. And here in this we are able to see the screw conveyors, that is from the silos how the cement is being taken to the mixture machine, and there is a control room and a mixture pan, and this is how a typical batching plant will be. It will be having all these components within it. The aggregate bins and feeding mechanism is how we are feeding the aggregates from the bins to the measuring area. Balance and measuring system, how we are able to measure the specific quantity of the ingredients. Cement silos for storing cement and cementitious materials, and from there how we are getting the cement of required quantity to the mixture machine is through screw conveyors or belt conveyor, screw conveyor or bucket conveyor, and where we are storing water which is required for mixing, and this dispenser for chemical admixture is a mechanism for using the specified quantity of chemical admixtures. And the plant type, batching plant can be of a cyclic or continuous type. A batching plant can be a cyclic or a continuous type, or can be automatic or manual. Batching plant type. cyclic, automatic or manual, cyclic or continuous. This batching plant can be of either cyclic or continuous type and automatic or manual type. The cyclic or continuous type is required where a large scale of production is to be done, and mostly in our scenario we are not using this type of continuous batching plan. We are in RMCs, we are going for automatic type, that is a control. The cyclic or continuous system is used where a large quantity of production is to be done. In our Indian scenario, we are not using this continuous batching process, whereas in RMCs we are going for this automatic type of batching, and in some cases it can be of manual type too. Next is the measurement. How the measurements are being made in the RMC plants. In olden days we had mechanical lever systems for measuring the mass of specified quantities, but nowadays we are going for load cells. Here these load cells are calculating the cumulative weight, that is, first the aggregates are being transferred to the buckets, that weight will be noted, then comes the cement. Now the cumulative weight of both aggregate and cement will be noted. Likewise, we are going for load cells to measure the mass of the ingredients. And discharge. Since we are having silos and storage tank for water, how the required quantity is being discharged from them to the mixing area plays a major role, and this discharge of specified quantities can be achieved through gates operated by compressed air cylinders. So, if a specified quantity of cement is being taken from the silos, there the discharge gate will be open. After the specified quantity is being fed into the mixer machine, then that discharge gate will be closed by the compressed air cylinders, which is being operated by a computer. Next, to measure the moisture content in the aggregates, we are using electrical or microwave gauges. So, the aggregate which is going into the concrete is either in SSD condition or it has a moisture condition. We can check so that the required corrections can be made. Suppose if a aggregate containing moisture is added to the concrete, then there is an increase in the weight of aggregate, so that we will not be able to get a concrete of required property. So, to measure the moisture content of aggregates, we are using either electrical or microwave gauges, so that by inserting these gauges, we will be able to find the moisture content, percentage of moisture content in the aggregates. Since the water is being also stored in the storage tanks, how the water is being measured. Water through flow meters. So this water is, the water of required quantity is measured through these flow meters, and in some cases they are measuring in terms of weight also. So in this way RMC batching plant is making a concrete of required property. They will be having a storage mechanism, a feeding mechanism, and they will be having a feeding mechanism, a storage mechanism, and a pre-desired weights which will be given to the computers, and based on that pre-desired weights they will be operating the gates and buckets to which the ingredients are being passed, and after that the mixing is done. In these ways a concrete is being batched in a RMC batching plant. Next we will discuss about mixing. After measuring the ingredients of specified quantity, we should mix them in order to produce a concrete of uniform quality. Essential for production of uniform quality. So this mixing plays a major role for producing concrete of uniform quality, and the equipments which we are using to achieve this mixing process should be capable of doing an efficient mixing. As that of a batching plant, here a mixing can also be cyclic or gravity mixers or counterflow mixers. Since mixing of ingredients, we are mixing ingredients of different specific gravity and different size ranges and different amounts, so that we have to mix it properly to attain a concrete of desired property. And a concrete, when mixed in dry stage, it is too difficult when compared to that of the wet state. So the mixing plays a major role to get a uniform quality of concrete throughout the entire batching process. So for a batch of concrete, right from the end, for a batch of concrete to be made, starting from first to last, my mixing quality should be the same to produce concrete of desired property. That is, if I take a sample from the first batch and at the last batch, I should get both a same slump value, so that I can ensure that my mixing process is the same throughout the entire period. So that mixing process can be cyclic or gravity or counterflow mixtures. Again, this cyclic mixer is used in places where the concrete production is large, where the concrete production is continuous, mostly in prefabricated sites. The cyclic mixture type is used where the concrete production has to be continuous and where the concrete is to be produced in a large amount. This gravity mixer works based on This gravity mixture works based on force movements. Using some forced movements, we'll be able to mix the concrete ingredients. Either it can be this gravity mixer uses some forced movements to make the ingredients mixed, and it is of mostly non-tilting or tilting type. This gravity mixture will cause some movements using the baffles within the mixer drum, and they will be able to achieve the proper mixing, and it can be of either non-tilting or tilting type. And this counterflow mixtures or open pan mixers, in this counterflow mixtures, the end through which there will be two ends. Through one end, the ingredients of the concrete will come into the counterflow mixers and it will rotate in clockwise, and at the other end there will be the discharge point. At the time of discharge, based on the action, that is counterclockwise, the drum will rotate in the counterclockwise direction and the concrete is being discharged through the discharge end, that is counterflow mixtures. And this open pan mixtures is mostly used in RMC plants. This open pan mixtures will allow us to get better mixing of ingredients. Next, mixing time. This mixing time also plays a major role to get concrete of uniform quality. So in a batch of concrete made, the mixing time should be the same for every batch of concrete being made. So that usually depends on slope and time duration is small. This mixing time should be small, and also within that small duration we should be able to achieve the right mixing of the ingredients. If a uniformity test is to be done on the fresh samples of the prepared concrete, then the samples which is taken at different stages should exhibit the same characteristics, so that we can ensure our mixing process is correct. This mixing time is 1 minute for 0.75 meter cube capacity mixer, 0.25 minutes for, and an additional 0.25 minutes for each additional capacity mixture. If our capacity mixture is 0.75 meter cube, then 1 minute is required for the complete mixing of the ingredients, or for additional increase in the capacity mixture, and another 0.25 minute can be given for mixing the ingredients. And this is how the mixing is being done in an RMC plan. In RMC plans we are using open type pan mixtures, and that's all about batching and mixing. So a typical RMC plan has its own components for batching processes and mixing processes, so that an efficient engineered concrete can be made out of it.